Hey everyone, KP the Math G here once again to do another video here. Hey, look at that. We're doing the 2025 free response question number 6. I almost elected not to do part A, but I taught this before, and you learn stuff and you learn how to do it, but then if you haven't gone over it in a while, you may forget how to do it. Now, some of you may be, oh, this is a breeze. Well, to some of you, it may not be a breeze. And so let's talk about this just for a little bit. That's a nice little problem. So how do we find dy over dx from this equation here? This is a curve G, by the way. That matches KP the Math G, huh? Oh, no. Coincidence. All right, let's get started. All right, we gotta get this right here, don't we? All right. Well, let's do. Anytime you deal with finding the derivative of y, all you do is tack dy over dx on the end of it. Just do that, because this is what you're doing when you're dealing with this. You just do that, because anytime you have both x and y, I want to call that implicit differentiation. I think that's right. Alright, so it's been a long time since I can't remember the terms all together, but anyway, just tag it on there. 2y dy over dx, you're differentiating y. Alright, minus 1, derivative of y is 1, times dy over dx plus, well, let's see here. Well, let's see, we've got to multiply 4 times 2. So 2 times 1/4 x, raise it to the 1. Now, we don't tack a dy over dx here because we didn't differentiate y, we just differentiated x. You still find the derivative of x here, but you don't tack a dy over dx on that. So maybe that's your problem. Maybe that's what you need to remember. Now this is 2/4, which is 1/2. Okay, so 2 over 4, which is 1 over 2. 1 over 2, right there. Now, equals, of course, the derivative of 0 is 0. Alright, now, this what I'm fixing to do is just move this to the other side. And let's factor out the dy over dx. Dy over dx. Just, what are you left with? 3y squared minus 2y minus, and some people leave off this 1. You did take something out. It's a, the derivative of y is 1, but then dy over dx. So sometimes that one's left out. And then you bring this to the other side. So this is plus, so this would be negative. And I like to think maybe this is, 1 times x is x. So this can be written, so 1/2 x times x over 1 is just simply x over 2, right? Alright, so negative x over 2. Alright. Now we got to divide this. Now notice I put the 2 on the side for a reason, right? When you divide this, all you're doing is you're just putting this in this denominator here. So we're dividing this side by dy 3y squared minus 2y minus 1. And of course that's going to divide out, and we just put it on this side as well, 3y squared minus 2y. Let's extend this. Okay, minus 2y minus 1. And let's move our negative x over to in the middle. And there it is. Put parentheses around that, and there it is. So, you know, I could turn this over, but anyway, dy over dx equals that. There it is. Not too much really to show, other than to say that when you take the derivative of y, you know, you're just going to put dy over dx. Okay. Remember now, there are related rates, and when you do a related rate, you're talking about time. So when you're doing that, this will be dy over dt, dy over dt, dy over dt. This would be dx over dt. So that's the difference between related rates and just, I want to say, implicit differentiation. Okay? And so this kind of differentiation where you just have y and x, and if you're wanting to find dy over dx, this is to be done. It's still a, it still needs to, you still need to take the derivative of that, but you don't tack anything on the end of that. That's it, right here. Okay, so that's what you got to show, and that's all you got to do with that. So that's it with this. Just know there are, you know, just take out that, excuse me, take out that dy over dx right here, here, and here, and you're left with these three here. Alright, and then take this on the other side. I knew this was going to be x over 2, so negative x over 2 like that. So you can do that. I kind of cut some corners there, but when you divide here, just simply put this in this denominator right here. Okay? Alright, so, alright, that's all I have here. That is part A. This is going to make the 176th YouTube video. I appreciate, I did get some more subscriptions. Well, only one more, but hey, it put me up to 100, and kind of pleased with that. Took a long time to get there, and I haven't done videos in a long time, so I probably could have gotten it a little bit sooner than that, but you know, I've been so busy doing other things. But anyway, this is what we're talking about here, and maybe even if you know how to do it, this might just sharpen your memory a little bit on how to go about doing this. Okay, part D is going to be a dy over dt or dx over dt. As a matter of fact, we know that what dx over dt is. We just need to find dy over dt, and those are called related rates. I love related rate problems. I just really love them. Some of them are a little challenging, more challenging than others, especially when you have to do something like d theta over dt. But even that, still, it's not super bad. So, alright. That's KP the Math G, getting ready to sign off. Ladies and gentlemen, if you want to subscribe, please do so. If you want to make a comment, please do so. If you like to make a you know, hit that like button. Hit that like button. You know, I always say in all my videos that I have that little smile on my face when I do that. So yeah, just do that. I mean, you don't have to, You don't have to do any of that. Again, I don't get any glory out of doing this other than the satisfaction that at 65 years of age I can still do it, right? I like that. So keeps my mind sharp too. But really, in all, this is for you, not for me. So if there's any way I can help with me and my markers and little whiteboard right here, if I can help you with that and using this, and this benefits you, so be it. Alright, well anyway, KP the Math G signing off. Ladies and gentlemen, have a great day.